Today we're talking about horizontal crack repairs in primarily residential foundations, guidelines, correct repairs, incorrect repairs. I'm Roger Pace, the owner of Avalon Structural Inc., 35 years of foundation repair experience, and this is
Bob Patterson, civil engineer, consulting with Avalon and other firms for over 40 years.
I'm Dylan Pace, EIT Vice President at Avalon. I've got an MS in geotechnical engineering, and looking forward to talk with you today.
So today we're going to talk about horizontal cracks in concrete, primarily residential foundations. Now this is important because a horizontal crack is a disconnect within the foundation, and so the foundation is compromised seismically. Behind us here is a pile of concrete from horizontal crack repairs, and we'll get into that further. We're going to cover today why it's important to fix horizontal cracks, incorrect repairs, codes and guidelines on correct repairs, proper engineered repair in our opinion, and key takeaways.
What causes horizontal cracks? Now, horizontal cracks are not caused by normal foundation issues like differential settlement. Those kinds of issues cause vertical cracks or sometimes diagonal cracks. On the other hand, horizontal cracks are almost always caused by the rusting of the horizontal rebar. And what causes the horizontal rebar to rust? In our professional experience, the central cause of rusted horizontal rebar is when it's originally placed too close to the edge of the concrete. When it's too close, it's much easier for moisture and air to reach the rebar, accelerating the rusting processes. And the other causes that we find are an existing vertical crack that allows the rebar to have the same issues rusting from that exposure. And the third cause in our experience is a chloride ion attack from a leaking water softener or other chemical source that will very quickly accelerate rusting.
Yeah, if I can interject, we find this in San Jose often at the backs of garages where often water softeners were placed. And when those leak and that chloride attack happens, those are devastating to a foundation. It's a very rapid acceleration. It's like a cancer, boom, grows, and those are the worst. And the concrete around the rebar will be itself very heavily damaged. It'll be very soft, chips out easily, and it's important for the contractor to remove all of that, get that chloride out, and take it from there. A fourth cause of horizontal cracks is rebar having been placed on top of form ties before concrete placement. In the humid environment common to subareas, these rusting metal form ties relay rust to the rebar. We see this frequently. The rusting rebar is just behind the crack in this scenario, although it can meander. Foundation contractors should be advised to avoid contact of rebar with non-galvanized form ties which pass through the foundation. They can be a conduit for rust.
Okay, how is rust so powerful? Dylan is holding this piece of corroded rebar here, which is rusted, and I don't know if you can see this in the camera, but it's just eaten away here. And as it does, as Roger mentioned previously, it attacks the concrete as well. And Dylan's going to explain a little bit more about the chemical process of this interaction.
Right, so the iron in the steel interacts with the oxygen to form iron oxide, which is 7 times larger than the base metal. And this expansion can cause a force of up to 9,000 pounds per square inch, which is a considerable amount of force on the concrete that it cannot withstand.
We've included crack example number 6, the offset crack, to demonstrate that although the crack emanates from the rebar, it does not always manifest at the rebar. So one has to just remove the concrete and find the damaged rebar. Some contractors will state in their contract that they will chip around the horizontal crack 3 inches and if no rebar is found, that they'll just patch the concrete. I'm sorry, but that is an insufficient repair. That is superficial.
Now we're moving on to part 2 with codes and authoritative guidance. Now, the relevant codes are produced by the ACI, the American Concrete Institute, and the ICRI, the International Concrete Repair Institute.
ACI 56221 for existing concrete structures, ACI 54614, the Guide to Concrete Repair, ACI 22407 for causes, evaluation, and repair of cracks in concrete structures, ACI 44007, the report on fiber reinforced polymers for concrete structures, ICRI 310 2008 for the repair of deteriorating concrete resulting from reinforcing steel corrosion. However, the sad truth is that there is no authoritative or enforceable code specifically addressing the proper repair of horizontal cracks in California. ACI 54614, the Guide to Concrete Repair, has a section on cracks, which states that the causes of cracks shall be assessed, and the mitigation of cracking shall be considered in the repair design. As part of a repair design, cracking mitigation methods shall consider the causes, movement, size, orientation, width, and pattern of the cracks. However, it is not uncommon that a concrete repair involves replacing only deteriorated concrete at spalls or delaminations. This approach often leaves chloride-contaminated concrete surrounding the repair area, creating a highly conducive environment for continued corrosion of the reinforcement. Such repairs may actually promote corrosion of the reinforcing steel in the surrounding concrete. ICRI 310 for the repair deteriorated concrete resulting from reinforcement steel corrosion is the most on-point piece of code guidance we have. And it states that the practice of completely removing the concrete, undercutting, from around the corroded reinforcement, no matter what degree of corrosion is found, is key to achieving long-term performance of surface repairs. In most cases, complete removal of the concrete from around the reinforcing steel is the best practice, where protection of reinforcing steel within the repair cavity is achieved by providing a uniform chemical environment around the reinforcing steel. ICRI 310 Section 6 states that the repair area should extend a minimum of 6 inches beyond the actual delaminated concrete. Note that during concrete removal, repair areas can grow in size beyond the areas identified due to incipient delaminations that are not readily identifiable by sounding. Our thoughts on this are that for the standard 8-inch thick foundation, this implies that a replacement of the entire width of foundation, a full depth replacement, is the best practice. ICRI 310 Section 8 for the inspection and repair of reinforcing steel states that if reinforcing steel has lost cross-sectional area, a structural engineer should be consulted. Our thoughts on this are that the repair of horizontal cracks should always involve the expertise of a licensed design professional, such as a professional engineer. ICRI 310 Section 6 for the configuration of the repair area states that repair configuration should be kept as simple as possible, preferably square or rectangular with square corners. This may result in removal of sound concrete, but re-entrant corners should be minimized or avoided as they are susceptible to cracking. Finally, ICRI 310 in their summary section states that understanding the existing conditions and cause of corrosion will assist the engineer in specifying the type and extent of the repair required. Our thoughts on this are that the licensed design professional can determine the cause of the problem and craft the correct solution. ACA 54614, concerning fiber reinforced polymer applications, states that FRP strengthened systems have performed successfully through earthquakes and have generally performed as designed in field applications. However, for bonded applications such as beams, slabs, and walls, the concrete should be sound, and proper surface preparations of the concrete substrate should follow the guidelines. Our thoughts on this are that to ensure the concrete is sound, the corrosion problem must be addressed, with all corroded rebar removed and all damaged concrete replaced. ACI 56221 states that FRP systems should only be installed in or on sound concrete. Concrete distress, deterioration, and corrosion reinforcement should be evaluated and addressed before the application of the FRP system. Our thoughts on this are that further corrosion of the rebar must be prevented to safeguard the concrete, and therefore, the FRP is not a complete solution for horizontal crack repair programs. Finally, we'd like to note that ACI 562, a very important but very flexible code, has already been adopted in Florida, Hawaii, North Carolina, Ohio, and the city of Austin, Texas, and it's under review in many other states as well. It would be smart to follow this code now, as it is likely to be part of the law of California, and it just makes sense.
Okay, according to the ICRI, you want to remove the concrete at 6 inches from the affected area. Now that's 6 inches in all directions. If this is the affected area of the rebar, you not only want to go 6 inches beyond, you want to go below, above, and out to the sides, which essentially means removing the whole section of concrete from that area.
So our thoughts on this: with a typical 8-inch wide stem wall, you're only leaving 2 inches, and that's if it was at the very surface. So it makes no sense to try to just chip at the horizontal crack. You've just got to lop off the stem wall, and be sure you get from the point of delamination 6 inches down, and then of course that means taking off the top of the stem wall, the whole width of the stem wall. Our thoughts: for a standard 8-inch wide stem wall, this implies full depth replacement is the best practice. A quick note about rebar: we like to use epoxy coated rebar as another line of defense. Other contractors don't like epoxy coated, some like chrome. It can be regular rebar provided it's placed in the center widthwise of the stem wall, and that any kind of salt issue has been remedied by removing any salt damaged concrete, and the source of that has been found and eliminated.
Now I want to talk about pop-out repairs. In our decades of experience, only about 1 in 10 or 10% of the repairs we see are true pop-outs, where there's no crack continuing from the issue all the way through. So only 10% of these are truly a local problem that don't extend. For the other 90% of foundation repairs of horizontal cracks, there is a through crack. And the pop-out repair fails for 3 reasons. For 1, it doesn't repair all of the damaged concrete. For 2, the rust will continue to propagate, endangering the rebar further and all of the concrete. But the third and most important reason is that the foundation is fundamentally disconnected, the top half from the lower half, which endangers the whole house seismically.
In this photo, we have evidence the crack is a through crack, as water has been passing through the crack, leaving mineral deposits, or efflorescence, on the face below. Any anchor bolts along this crack are severely compromised, if not rendered useless.
Fiber repair gone wrong. Can you spot the failures in this photograph? Number 1, the crack was discontinued. The repair was discontinued. They didn't do all of the crack. Number 2, it's an irregular area, not in accordance with the International Concrete Repair Institute. They didn't do a full depth repair. And finally, the FRP just peeled off on its own. Now, FRP is a great product to wrap a beam or column, gives it extra strength, many applications. But why apply it in this scenario? I've seen it used too many times as a cover-up for an improper repair. Now, this job in question, it was a permitted job. The contractor got a permit. He or she pulled the wool over the plan checker, the inspector, and the homeowner. Well, when the FRP fell off, the homeowner followed us, and that's when we saw these errors.
This is the actual grout used in this repair, recovered from the site after the FRP cover-up peeled off on its own. It was sold to the client as an epoxy grout. As you can see, it is a very low PSI, strength, and adhesion. Another example of a cheap and improper repair. Epoxy was smeared over the horizontal crack. As the damage was not repaired per the ICRI guidelines, which includes engineer oversight, the rebar continued to expand and the area opened again. The grout at the center of the photo indicates a pop-out repair was done. Damage continued to occur. We can see the cracking continued sometime after the repair was done, as the root cause was not remedied. Later, we'll produce a lengthy video concerning vertical cracks, but a brief mention of the subject is relevant here. In residential foundations, we are not concerned with dry shrinkage cracks which do not admit atmosphere to the horizontal rebar. These are truly hairline vertical cracks, such as the crack to the left in this image. However, vertical cracks wide enough to admit atmosphere to the horizontal rebar should be addressed. These we call significant cracks. Cracks are, of course, a relief of stress. They are an effect and not a cause. Some cracks are wider at the top, such as this crack. Some cracks are wider at the bottom. Such vertical cracks, which are wider at one end, are related to differential settlement. Repair of these cracks will not arrest the differential settlement of the foundation. Some cracks are uniform top to bottom, such as this crack. Note to home inspectors, please do not place marks across the crack, as this may inhibit epoxy adhesion. Some cracks exhibit an offset or rotation, a more serious problem. These should be brought to the attention of the project engineer. Injection from below until epoxy spills from top of concrete.
In this next slide, you'll see a presentation of a cross-section of a concrete engineered design being restored. It's very straightforward. You'll see that the concrete has been removed to a point 6 inches below the crack. This is particularly important when chemical attack occurs. Now the section has been restored and is acting as a unibody, as Dylan pointed out in the previous section.
Key takeaways. Firstly, on corrosion. Rusting rebar is #1 cause for horizontal cracks. And remember, the rust can exert up to 9,000 pounds per square inch on the concrete, which you just can't withstand. Secondly, we have the guidelines. Now, there is no code specifically addressing the repair of horizontal cracks. However, there's plenty of guidelines that do tell us the correct approaches to take.
Best practice. For a standard 8-inch wide stem wall, it is to remove the full width of the stem wall, not just a surface repair. Faulty repairs. Superficial repairs are cheap. They make the contractor lots of money. They're easy to do. They do not fix the foundation. They do not reconnect it. 90% of horizontal cracks are through cracks, disconnections, and only lopping off that stem wall and replacing it is going to fix that.
Lastly, I'd like to speak about engineering participation. Engineering is critical in the design and inspection of a properly done horizontal crack repairs. This will ensure the homeowner and the contractor that the repairs have been done properly.
Thank you for watching. Comments are welcome.